In this notebook, we will combine information from some municipality polygons and a list of different healthcare districts in Finland to create polygons with that information of which healthcare districts they belong to. So this is a tutorial kind of where we will be cleaning or reading in some data, cleaning it, and then doing some joins and dissolving geometries based on municipality and region. Okay, so and yeah, again, just let me know if there's anything unclear or I need to repeat. Post in the chat. But if there are no questions at this point, I will jump straight into it. So yes, we'll start by just reading in these import statements of which packages we need, and then getting into the data that we are using. So we will be reading the data from a web feature service from Statistics Finland that has municipality polygons that we want to use from this feature. So we have here the URL of that web feature service request. And as you have seen before, we can then take that and read that in with GeoPandas. So let's go ahead and do that and then check out what data we get. So with GeoPandas, we can read a file and pass it the URL, because this request returns a JSON file or GeoJSON. So let's read that file, the GeoJSON, into a geodata data frame and take a look at the result. Yes, so here we have a geodata frame with the different polygons and the names of the different municipalities in Finland. We can check the length of our data and see that we have 309 rows. So that is good. That represents the different 310 municipalities in Finland, except Åland. So I think so. We will be adding that later at the end when we're joining different data. But so far, let's work with the data that we have now. And let's rename some columns to make it a bit easier. And then also, we don't need all the different columns that are in the request that we got. So here we renamed Conda to code, and then use only the code and the name and the geometry columns from our data. So if we run this cell, you can see we have now a bit smaller geodata frame. So that is good. It's easy to work with. And then we will plot the we can plot the data to take a look and see how it looks. And we just do a quick and dirty plot here and see we have all of Finland and the different municipalities covered. So yes, we can even check the D types of our geodata frame to see that we have a geometry column that contains geometries, and then for code and name we have different objects. Yes, so that is the first data layer that we need. And then we want to take information of Finnish municipalities with health district information and join that into our geodata frame and our polygons there. So in our data folder, we have we should have a Excel sheet from 2020 that contains the different municipalities. Yes, it's this health district information where Åland is not included, but we will add that to our geodata frame in the end to have all municipalities in the different health districts. So what we need to, if we try to open his, we see we have a XLS file. So it's an Excel file of an old format, which sometimes might be hard to or difficult to read. So what we need to do in order to read that into our with Python is that we need to install a package in order to do that. And that is here it is. We have it as an example of that. Sometimes when you run into different file formats or different types of data, you might need to install a different package in order to be able to use that. So we will do that now. We will do that in the command line by running this command. So if we copy that, I'll copy it with Control-C, and then file, open a terminal. And then in our Conda environment that we are using, I will paste that with Control-V and run it. And that should first do some checks of our system. And if it's not installed already, then it will ask us to install it. I'm not sure, it might be installed on my instance. I think I maybe have done it before, but if you haven't, then running this code and then, yes. So here, when it then asks us to proceed with installing XLRD, then I type Y and enter, and it should install quite quickly. So maybe this is also a good time to do some green check marks if you have been able to install the Conda package using the terminal. It seems that most have been able to follow it, at least. So if you were not able to, what I did was copy the Conda install code here and paste it into the terminal and follow the instructions to install. So unless anyone puts up a red check mark or types in the chat, then I'll continue with reading in the data. Okay. So yes, encountering Excel files is quite common when doing data analysis. So here we will go through an example of how to read in the Excel files in Python. So let's create a new variable for our data and then use pandas to read in the data with the XLRD package. So we can do that by typing PD for pandas and then read Excel. And then we need to read in the or have the file path for our file. So it is here to the left. We can right click and copy path. Then we get a the full path, I think. Yes. So paste it in here. Actually, if we make that into a relative path by starting it with data, so it's in the data folder within the folder that we are in now. So under data, and then the name of our file. And for Excel sheets, we also need to pass it the name of our sheet that we are using. So that is under the parameter sheet equals, and then for simplicity's sake, we will copy the name of the sheet here. That is also includes the punctuation mark at the end. So here, as you might see, it's an example of a difficult sheet name with both spaces in the middle and some Scandic letters and punctuation, which is not the best practice, but something that you might often encounter as well. So as of now, let's try to see how the data looks like. So if we read it in and data.head, we got a type error because it's not sheet, but sheet name that is supposed to be here. So, okay, so as we can see now, we got some data read in, but we also can see that it doesn't necessarily look correct. So if we do some more rows in our data.head to see here that in fact, it looks like our data starts here at row index 4, but our headers are stored in row index number 2. So what we can do in this instance is to skip the first rows, and then to make sure that we start reading in at the row where our headers are, so that we can have those for later, and then drop one row of NaN values. So we can then when we read in the data, also pass it the header parameter, and then as our data is, or our headers is at let's see, yeah, it's in 0, 1, 2, but for PDXL, it reads it as 3 at the third row. So if we try that and see, now our data looks much nicer. And now we only have the first row that is of empty data that we need to take care of. Let's do that in the next cell. So here, if we want to drop the NA values, we can simply type data.drop NA and pass it the in place equals true to replace those values. So if we run that, that runs successfully, and we can then check out the length of our data to see how many rows we now have. So we have 294 rows of data. And as you remember, our data did not have the 16 Åland municipalities. So we will be adding those later. But other than that, it looks good. We can also just check our data.head to see that indeed we skipped the first row of missing values and now only have the correct values that we want. Okay. So let's try to rename some columns from Finnish to English to make it easier for me to pronounce, and also subset our data to only contain the code of our municipalities and the name of our healthcare districts that we are interested in. So here in this cell, if we run it, it will rename some columns and drop or subset our data to only the selected columns. To run that, take a look at our data and see that this looks much better. We now have the code and the healthcare district of that municipality. Okay, so now it's starting to look like something we can join together to join together our two data sets. So let's, before we do that, take a look at the types that our data is in. So if we take the data and the D types, we will see that our code data or code column is a float object, while our healthcare district is an object. So what we need to do now is to, as we see, our code column is a floating point object. So here 980.0, which is not the correct way of representing our municipality codes. We need to do something about that. So first, let's just take a look at the number to see that it's 20.0. While if we scroll up back to our geodata data frame, we can see the codes for all the municipalities is in a different format with leading zeros, as it's called. So 005, for example, or 010. While in our healthcare district data, we see it has a different format. So we need to convert the two, convert the municipality codes in our healthcare district data in order to be able to join based on the healthcare or the municipality code. So one simple or fast way to do this is to convert. First, we need to convert it to the number to a string, and then make sure it has leading zeros. So zeros also before the other numbers. And that is a quite common operation to do in data science and data cleaning. So we can use a function called setFill if we have a string. So first here I can give the example of how it works. So if we want to print, for example, here we have a string with 20, and then the function is called setFill for 0 fill, and then the number that we pass it here is how many numbers the resulting string will have. So if we pass it setFill 2, then the string will only be 20 because it has two numbers here. But if we pass it 3, then it will be 0 to 0. I hope that made sense. So what we can do then for our entire data frame here of our healthcare districts is to first convert the codes to to string, and then convert it to a and then make sure it follows the same naming convention as with leading zeros. So let's take our data in our code column and replace that with the data with the code column that we first need to convert it as type to a integer number, because first it's a floating number, and if we take away the decimal points by converting it to a integer, and then at the same time convert it again as type string str for string. So if we do that, we can also check our data.head and see now our numbers have been converted to integer numbers, but we then want to convert it to strings with a leading the leading zeros, either 1 or 2, based on the number it already has. So data and then code, we will replace that again with data code, and then use the str for string operations, and then set fill and 3. And if we then check out our head of the data, we can see we have converted it to numbers with leading zeros. So that is super, because that resembles the municipality codes that we had at the top here in our geodata data frame. Okay. So what we will do next is then to try to join our health district information into our municipality polygons, so that we, in the different polygons, have data also about which health district each of those municipalities belongs to. So that is a merging operation that we want to do to merge the different data sets together. So then we can start with our geodata, and we want to merge that with our healthcare data. And then we need to pass which condition or which column we want to merge based upon. And in this instance, it is the municipality code that it will be the common denominator for the two data sets. So we will pass on and then use code. And then how we want to merge, in this instance, we want to use the left, so that it takes all the instances where in our geodata and tries to join the data into that data frame. So let's store that into the geodata variable and run that, and then take a look at what the geodata now looks like after merging. So yes, now our geodata data frame has a polygon with and a municipality code. It has the name of the municipality and also the name of the healthcare district it belongs to. So that is good, but we can still need to add the island municipalities that are not in the data set, or they are in the data set, but they are not in the healthcare district data, because they all belong to Åland. So what we can do is in our we know that from our healthcare district data set, they were missing the Åland municipalities. So let's see if we can locate them in our geodata data frame. So in our geodata data frame here, let's select the geodata column, healthcare district, and see where that value is null, or it does not have a value. So that we can do with is null function and try to extract just the name from that columns. So here we can see those rows in our geodata frame that does not have a value in the healthcare district column are indeed these municipalities that belong to Åland. So what we can then do to update the districts to Åland, or set which district, healthcare district they belong to, we can then in our geodata locate all the rows where in geodata where the healthcare district again is null. And then if we here in the comma, pass it a comma, and then we can set or select that healthcare districts district, and we can set that to either Åland or the Finnish name as a string value. Let's see, I spotted a typo there. So here we within the geodata data frame, we locate the rows from the healthcare district column that is null, and we select the healthcare district column for those rows and set that to the value that we want. So if we run this cell, that should work, and we can try then inspect the data to see if it has been updated with the municipalities. So if we in the geodata frame select the healthcare district and again use the value counts function. My spelling is all over the place, but here we then can see how many polygons or how many municipalities that are in each healthcare district. So how many rows in our data frame there is, and we can see the ones we added are 16 municipalities. But so the last thing we want to do here is, now that we have joined our two data sets, we would like to both visualize and dissolve our data doing a geometric operations, which we talked about earlier today, to select or to group the municipalities that are in the same healthcare district. So let's do that by dissolving our data that we just created and create a districts variable. So we'll start by districts, create a variable. And what we want to do is to combine or dissolve the geodata frame that we just created. So our geodata frame, and then dissolve, which we saw earlier today. And if you remember, we then need to pass it it has a parameter called by, and where we define which column that we want to dissolve by. And in this case, it's the healthcare district column. So if we run that, it should run fine, and we can check a quick look. Take a quick look at districts here and see we have a new index which contains each of the districts, and they have a geometry. And also, as we talked about earlier today, it then contains the first instance of the combination or of the rows that it dissolves by. So even though there are more than that, Brende is not the only municipality in Åland healthcare district. It is the only one that is stored here. So let's try to clean up that. And what we can first do is to reset the index of our new districts data frame. So let's reset the index and also pass it in place equals true. There we go. And then we can, since these two last columns, the code and the name doesn't really make sense anymore, let's just drop them. So districts, let's replace that by districts and subset it to our health care districts and the geometry column. And we need to pass this as a list when subsetting. So, okay, let's take a new look at our districts. New data frame that has a new index with the healthcare care district, that's an own column, and the geometry column. So super. What we can then do is to quickly visualize our data. So if we take the district and plot it, it will show all of Finland again. But as we have learned how to classify today, we can also make it more clearer by classifying our data. So let's select the column that we want to inspect, healthcare district, to make sure that we have indeed classified it correctly or dissolved it correctly. And then let's use a CMap, color map of, let's take one that is called tab 20. And we have, yes, we have 21 districts, if I am not mistaken. So we have from 0 to 20. So let's do 21 classes and plot that. And we can indeed see that our different districts are plotted and look different from our initial municipality data that we saw on top here. So that is good. We can even remove the axis just to make it a bit more clear. Okay,